Addressing grounding in electrical boxes with older BX and Romex wiring can be challenging, especially when an equipment grounding conductor is absent. Here are several options to bring such installations up to code. Firstly, consider installing a grounding kit specifically designed for BX cable. These kits typically include a ground strap that you attach to the metal jacket of the BX cable, providing a grounding path. Then connect the ground wire from the kit to the metal box. This method utilizes the BX cable's metal sheath as a grounding conductor when properly bonded. Secondly, if feasible, run a new, properly sized grounding wire from the electrical panel directly to the metal box. Ensure that the grounding wire's size is appropriate for the circuits over current protection, referring to NEC Table 250.122 for guidance. Connect the grounding wire securely to the panel's grounding bus and to the metal box, establishing a dedicated grounding path. Thirdly, an alternative, though less ideal, method involves installing a ground rod near the electrical box. Drive the ground rod into the earth, ensuring it makes good contact with the surrounding soil. Then connect a jumper wire from the ground rod to the metal box. While this provides a path to ground, it's crucial to ensure that the ground rod is also electrically connected to the building's main grounding electrode system to comply with NEC requirements. It is important to note that using a ground rod in this manner might not provide the low impedance path necessary for effective fault clearing, so it should be supplemented with other grounding methods whenever possible. Addressing the issue of brittle wiring requires a delicate approach. Firstly, avoid bending or manipulating the old wiring unnecessarily, as this can easily cause it to crack or break. Handle the wires with extreme care, especially when making connections or moving them within the box. Secondly, when making connections, use wire nuts with bite guards. These specialized wire nuts have a plastic or metal insert that prevents the sharp edges of the wire nut from directly contacting the brittle wire, reducing the risk of breakage when tightened. Ensure that the wire nuts are properly sized for the number and gauge of wires being connected, referring to the wire nut manufacturer's specifications. Thirdly, if possible, consider replacing short, particularly brittle sections of wire with new, modern wiring. Carefully identify the areas where the insulation is cracked or the conductor is corroded, and cut out these sections. Ensure the new wire is the same gauge and type as the existing wire to maintain the circuit's integrity. Use appropriately sized wire connectors to join the new and old wires, ensuring a secure and reliable connection. When selecting wire connectors, consider using those that are specifically designed for joining dissimilar metals, as this can help prevent corrosion issues in the future. Remember that working with old wiring presents inherent risks, so prioritize safety above all else. Before starting any work, de-energize the circuit at the electrical panel to prevent electric shock. Wear appropriate personal protective equipment, such as safety glasses and insulated gloves, to protect yourself from potential hazards. If the wiring is severely damaged, deteriorated, or unsafe, it's always best to consult a qualified electrician for professional assessment and repair. An electrician has the expertise and tools to safely and effectively address complex wiring issues, ensuring that the electrical system is brought up to code and operates safely. When dealing with older electrical systems, it's also important to be aware of potential hazards such as asbestos insulation, which was commonly used in older wiring. If you suspect that asbestos is present, do not disturb the wiring and contact a qualified asbestos abatement professional to handle the situation safely. Furthermore, be mindful of the presence of lead paint, which was also commonly used in older homes. Take precautions to avoid creating dust or fumes when working near painted surfaces, and follow proper lead abatement procedures if necessary. When upgrading or modifying electrical systems in older homes, it's essential to ensure that the entire system is brought up to current code standards. This may involve upgrading the electrical panel, replacing old wiring, and installing ground fault circuit interrupter or GFCI protection in areas where it is required. GFCI protection is particularly important in wet or damp locations such as bathrooms, kitchens, and outdoor areas, as it can help prevent electric shock. It is also important to ensure that all electrical work is performed by a qualified and licensed electrician who is familiar with the requirements of the National Electrical Code, or NEC, and local electrical codes. A qualified electrician can ensure that the electrical system is installed safely and correctly, minimizing the risk of electrical hazards. Remember that electrical work can be dangerous, and it's always best to err on the side of caution. If you are not comfortable working with electricity, do not attempt to do the work yourself. Instead, hire a qualified electrician to do the job for you. In addition to addressing grounding and brittle wiring, it's also important to inspect the condition of the electrical box itself. If the box is damaged, corroded, or otherwise in poor condition, it should be replaced with a new one. Ensure that the new box is properly sized for the number of wires and devices it will contain, and that it is securely mounted to the wall or ceiling. When replacing an electrical box, be sure to use a metal box if the existing wiring is BX cable, as required by code. This ensures that the metal sheath of the BX cable is properly grounded. When making wire connections inside the electrical box, use appropriately sized wire connectors and ensure that the connections are tight and secure. Loose or corroded connections can cause overheating and electrical hazards. To improve the safety and reliability of the electrical system, consider installing arc fault circuit interrupter, or FSI, breakers in the electrical panel. FSI breakers are designed to detect arc faults, which are a common cause of electrical fires, and to trip the circuit before a fire can start. FSI protection is required in many areas of the home, particularly in bedrooms and living areas. When working with older electrical systems, it's also important to be aware of the potential for overloaded circuits. Overloaded circuits can cause overheating and electrical fires. To prevent overloading, avoid plugging too many devices into a single circuit, and consider adding new circuits if necessary to distribute the electrical load more evenly. When adding new circuits, be sure to use the appropriate size wire and breaker for the intended load. Refer to the NEC for guidance on sizing conductors and overcurrent protection devices. In addition to addressing specific issues such as grounding and brittle wiring, it's also important to conduct a thorough inspection of the entire electrical system to identify any other potential problems. This inspection should include checking the condition of the wiring, outlets, switches, and other electrical components. Any damaged or defective components should be replaced promptly. Finally, remember that electrical codes and regulations are constantly evolving, so it's important to stay up to date on the latest requirements. Consult with a qualified electrician or electrical inspector to ensure that your electrical system is in compliance with all applicable codes and regulations. By taking these steps, you can help ensure the safety and reliability of your electrical system and protect your home and family from electrical hazards. Remember that working with electricity can be dangerous, and it's always best to err on the side of caution. If you are not comfortable working with electricity, do not attempt to do the work yourself. Instead, hire a qualified electrician to do the job for you. When dealing with older electrical systems, it's particularly important to exercise caution and to follow all necessary safety precautions. Old wiring can be brittle, damaged, and potentially hazardous. By taking the time to address these issues properly, you can help ensure the safety and reliability of your electrical system for years to come. Also, when installing a ground rod, it's imperative to adhere to NEC section 250.53 regarding its insulation depth and resistance to earth. The NEC typically requires a ground rod to be driven at least 8 feet into the ground and to have a resistance to ground of 25 ohms or less. If a single ground rod does not achieve this resistance, an additional ground rod may be required. Proper grounding is essential for electrical safety, as it provides a low impedance path for fault current to return to the source, tripping the overcurrent protection device and preventing electrical shock hazards. In addition to ground rods, other grounding electrodes may be used, such as metal underground water pipes or metal building frames, provided they meet the requirements of the NEC. When using a metal underground water pipe as a grounding electrode, it must be supplemented by another electrode, such as a ground rod or ground ring. Furthermore, when dealing with BX cable, it's crucial to ensure that the connectors used to terminate the cable are listed for use with BX cable and that they provide a reliable electrical connection to the metal sheath. These connectors typically have a built-in grounding means that allows the metal sheath to be connected to the grounding system. When installing BX cable, it's also important to avoid kinking or bending the cable excessively, as this can damage the metal sheath and compromise its grounding capabilities. The cable should be supported at intervals specified by the NEC to prevent strain on the connectors and to maintain its integrity. In addition to the grounding methods mentioned earlier, another option for grounding electrical boxes in older homes is to utilize the equipment grounding conductor of a nearby circuit. This can be accomplished by running a grounding wire from the grounding terminal of an outlet or fixture on a nearby circuit to the metal box in question. However, this method is only permitted if the nearby circuit has an equipment grounding conductor that is properly sized and connected to the building's grounding system. Before using this method, it's essential to verify that the nearby circuit's grounding system is adequate and that the grounding wire is properly sized for the circuit's overcurrent protection. When selecting wire connectors for use with older wiring, it's important to choose connectors that are compatible with the type of wire being used. For example, if the wiring is aluminum, use connectors that are specifically designed for use with aluminum wire to prevent corrosion and ensure a reliable connection. Similarly, if the wiring is copper, use connectors that are compatible with copper wire. It's also important to ensure that the wire connectors are properly sized for the gauge of wire being used. Using undersized connectors can result in loose connections and overheating, while using oversized connectors can make it difficult to achieve a secure connection. When making wire connections, be sure to strip the insulation from the wires carefully to avoid nicking or damaging the conductors. Use a wire stripper tool to remove the insulation cleanly and without damaging the wire. After stripping the insulation, twist the wires together tightly using lineman's pliers or similar tool. Then, screw the wire connector onto the twisted wires, ensuring that it is securely tightened. After installing the wire connector, give the wires a gentle tug to verify that the connection is secure. If the wires come loose, remove the connector and remake the connection. When working with older wiring, it's also important to be aware of the potential for knob and tube wiring. Knob and tube wiring is an older type of wiring that was commonly used in homes built before the 1940s. It consists of single conductor wires that are supported by porcelain knobs and tubes. Knob and tube wiring is generally considered to be unsafe and should be replaced whenever possible. If you encounter knob and tube wiring in a home, it's important to consult with a qualified electrician to determine the best course of action. In some cases, it may be possible to leave the knob and tube wiring in place, provided that it is in good condition and meets certain safety requirements. However, in most cases, it's recommended to replace the knob and tube wiring with modern wiring. When replacing knob and tube wiring, it's important to disconnect the old wiring completely and to remove it from the building. The new wiring should be installed in accordance with the NEC and all applicable local codes. In addition to knob and tube wiring, another potential hazard in older homes is asbestos insulation. Asbestos is a mineral fiber that was commonly used in insulation materials before its health hazards were recognized. Asbestos can be found in a variety of building materials, including pipe insulation, drywall, and floor tiles. If you suspect that asbestos is present in a home, it's important to avoid disturbing the material and to contact a qualified asbestos abatement professional to handle the situation safely. Asbestos abatement professionals have the training and equipment necessary to remove asbestos-containing materials safely and to dispose of them properly. Finally, remember that electrical work can be dangerous, and it's always best to err on the side of caution. If you are not comfortable working with electricity, do not attempt to do the work yourself. Instead, hire a qualified electrician to do the job for you. A qualified electrician has the training, experience, and tools necessary to perform electrical work safely and correctly. By hiring a qualified electrician, you can help ensure the safety of your home and family and protect yourself from electrical hazards.